Episode 16, Define Precise, Testable Software Security Requirements, we focus on the moment where ideas about security stop being good intentions and become crisp sentences that guide design and testing. Many projects talk about building in security, but the only parts that consistently survive into code, tests, and audits are the requirements that are written down clearly. The promise here is straightforward. By the end of this discussion, the phrase security requirement will mean something specific, verifiable, and useful rather than a vague wish. When requirements are framed this way, architects know what to design, testers know what to prove, and stakeholders understand what they are actually getting. Clear requirements are not paperwork. They are the bridge between risk thinking and reliable implementation. A good starting point is the discipline of writing atomic statements, so each requirement expresses one idea, has a clear subject, and describes a measurable outcome. Atomic means avoiding blended sentences that try to cover logging, access control, and encryption all at once, because those fragments are impossible to trace or test independently. A clear subject names who or what must behave a certain way, whether it is a service, component, process, or role. A measurable outcome states what success looks like in terms that can be observed or verified, rather than emotional phrases such as adequate or robust. When requirements are written as single, focused statements, they can be prioritized, owned, and tested with far fewer arguments. Language choice matters just as much as structure, so consistent verbs that avoid ambiguity, hedging, and implied assumptions are essential. Verbs like must, shall, and will convey obligation, whereas should, might, or could leave room for interpretation and quiet erosion of intent. Phrases such as appropriate, where possible, or to a reasonable extent sound reasonable but dodge accountability, because nobody can agree objectively on what they mean. Implied assumptions, such as the system prevents unauthorized access, hide complexity and make it unclear whether the requirement refers to authentication, authorization, session management, or something else. Choosing precise verbs and avoiding hedged qualifiers pushes the team to state what exactly the system is expected to do. Every worthwhile security requirement should have visible roots in risks, threats, and business objectives, rather than appearing from thin air. Linking a requirement to a specific threat scenario, such as credential stuffing or lateral movement, clarifies why it exists and how it reduces exposure. Connecting it to a business objective, like protecting payment data, maintaining service continuity, or meeting regulatory obligations, helps non-technical stakeholders understand its value. This traceability also supports prioritization when resources are limited, because requirements tied to higher impact risks or critical objectives naturally move earlier in the queue. Over time, a requirement set that is visibly grounded in risk and business direction commands far more respect than one that appears as a generic checklist. Acceptance criteria turn the promise of a requirement into concrete proof, describing how success is demonstrated under both normal and failure conditions. These criteria might specify the data, scenarios, or test methods that show the requirement is met, such as specific error responses, log entries, or behaviors under load. Normal conditions confirm that the feature works as intended in everyday use, while failure conditions explore what happens when inputs are malformed, dependencies fail, or users behave unexpectedly. A requirement without acceptance criteria invites disagreement later about whether enough has been done, particularly when deadlines approach. Well-written criteria, on the other hand, give architects, developers, and testers a shared target they can all recognize. Security requirements are not limited to visible features. They must also capture non-functional needs around confidentiality, integrity, availability, and resiliency. These non-functional expectations describe how the system should handle sensitive data, maintain trustworthy state, remain accessible to legitimate users, and recover from disruptions. They might spell out acceptable downtime limits, data classification handling rules, consistency requirements for critical transactions, or tolerable data loss in extreme scenarios. Without these explicit statements, teams rely on implicit assumptions that often differ across roles and departments. Writing non-functional requirements in the same crisp, verifiable style as functional ones ensures that quality attributes receive the same level of discipline as features. Constraints are another crucial part of clear requirements, covering environments, dependencies, interfaces, and operational guardrails explicitly. A requirement might specify that it applies to production and staging environments, but not to disposable test sandboxes, or that it depends on a particular identity provider or logging platform. Interface constraints describe how external and internal clients can interact with the system, including protocols, authentication methods, and expected behaviors on failure. Operational guardrails might include maintenance windows, deployment patterns, or restrictions on where data can be stored geographically. When these constraints are written down, teams are less likely to discover late that a requirement was impossible or misapplied. Misuse and abuse cases extend requirements into the negative space, intentionally describing behaviors that must not occur and conditions that must be resisted. These cases might capture scenarios where users attempt to bypass controls, replay tokens, escalate privileges, or exfiltrate data through unusual pathways. By articulating these concerns, you invite designers and testers to think like adversaries, not just like supportive users. Negative cases can be paired with positive requirements, reinforcing both what must happen and what must never happen. This dual view reduces the risk that a system passes all its happy path tests while remaining vulnerable to simple, foreseeable misuse. Feasibility is essential because even the clearest requirement fails if it cannot be delivered with available owners, resources, timelines, and upstream dependencies. A requirement that assumes a logging platform, token service, or secrets vault that does not yet exist will stall unless those dependencies are acknowledged and scheduled. Ownership clarifies which team is accountable for delivery, which is different from who may simply be interested or affected. Timelines should align with skill availability, competing priorities, and organizational constraints instead of assuming an ideal world. When feasibility is assessed alongside clarity, requirement sets become realistic plans rather than wish lists. Sound requirements also follow the familiar pattern of being specific, measurable, achievable, relevant, and time-bound, often shortened as SMRT, while remaining traceable and version-controlled. Specific and measurable help ensure that requirements are testable and unambiguous, while achievable reminds everyone to consider capacity and constraints. Relevant keeps each requirement linked to genuine risks and objectives, avoiding clutter that adds effort without value. Time-bound can apply to when a requirement must be met or when it will be revisited as technology and context evolve. Version control then records how requirements change over time, who approved those changes, and which designs and tests each version influenced, creating a collaborative history rather than isolated documents. Granularity is always a balancing act. Too coarse, and requirements are vague. Too fine, and they become brittle pseudo-designs. High-level statements like, "The system shall be secure," are meaningless, while low-level directions like, Use this particular library call in this function belong in design or implementation notes. Effective requirements sit in the middle, describing what behaviors and properties must exist without locking teams into specific code paths or tools. This allows for evolution in technology and architecture while preserving the original security intent. When granularity is chosen well, requirements remain stable even as solutions improve. Testability must be validated intentionally, not assumed, by walking through example checks, scenarios, and the types of evidence that would satisfy auditors or assessors. Teams can rehearse how they would prove a requirement is met, identifying which logs, reports, configuration snapshots, or test results would be presented. Scenario walkthroughs reveal gaps where a requirement sounds clear but produces ambiguous or conflicting interpretations when mapped to real flows. These rehearsals also show whether gathering evidence would be practical or imposes unreasonable monitoring and documentation overhead. When testability has been confirmed in this way, requirements become much more resilient under scrutiny. A brief mini-review helps reinforce the main patterns you are building. Clarity shows up in atomic statements, precise verbs, and visible links to risks and business goals. SMART framing combines specificity, measurability, relevance, and time awareness with realism about what teams can deliver. Feasibility and ownership connect requirements to real people, dependencies, and schedules instead of leaving them in abstract space. Testability and traceability ensure that every requirement can be proven and that its evolution is understood over time. Together, these qualities transform security requirements from decorative lists into working tools for design, development, and assessment. The conclusion for episode 16 is to bring this down to one immediate act of refinement. Choosing a single existing security requirement and rewriting it so that it is atomic, risk-linked, and framed with clear acceptance criteria will do more for understanding than drafting a dozen new statements. Adding those acceptance criteria makes it obvious what tests, evidence, and behaviors will be needed for success. From there, additional requirements can be improved in the same way, gradually raising the overall quality of the set. As this practice takes hold, both your exam preparation and your day-to-day work will benefit from requirements that genuinely guide secure software. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.